Hey there, how's it going? So in this tutorial, we're going to learn how to make this game called Breakout. Super old Atari game, and should be pretty straightforward. And what we're going to be doing for this is we're going to be, once again, using object-oriented programming, but we're going to make use of a little bit of inheritance in order to show how to do that effectively, as well as introduce a couple other new ideas that we didn't see when we were doing the target shooter game. So, this is the idea of what we're going to be finishing. And then after we have this done, you're going to be adding on to it by adding your own features and whatnot in order to make it a more interesting game. Sound good? Alright, let's get started. So, this is kind of where we're going to start off with. We're going to be importing a couple libraries here once again. So, we're going to import, of course, random. And we're going to want to import math. And once again, we're also going to be making use of the NumPy library. And I have not initialized it in this project yet. In yours, it probably will be initialized, but in case it's not, this is what you need to do. You need to go to the shell, and then you say pip install, and then the name of the library that you want to install, which in this case is NumPy. And so it's going to do its thing, take a little bit, and then after that we're going to be able to make use of the NumPy library. So I'm going to just go ahead and import it right away. But I'm only going to be importing some of the things from it. We're not going to be using all of NumPy. We're going to be using the array again so that we can treat it like a vector. You could use your own vector class that we made earlier, but for this we're just going to be using the one in NumPy, as well as matrix and matrix multiplying. So from NumPy, see here it successfully installed it, so we're good to go. So from NumPy, we're going to import array. We're also going to import matrix, and we're going to import matmul, which stands for matrix multiply. Okay. Array is once again just going to be our vector. Matrix is going to allow us to do some reflections a little bit in an easier way. So we saw how to bounce things off of the edges of the screen. This is going to help us bounce off corners as well, make it a little bit easier. And this is going to go along with it so that we can actually do the operation. So, that should be all the stuff that we need to import. Down here, let's set some stuff up. So, of course, we're going to initialize the game. After that, we're going to come up with how big our window height and window width is going to be. These are going to be global variables, so do it in all caps. And we'll say this is going to be 500 pixels tall and 800 pixels long. We want to use these values when we're creating our surface, so we are just going to plop them in right here. So this is going to be the window width. This is going to be the window height, so we can use those. And of course, we want to change our caption to be Breakout. And that'll be just what's displayed at the top of the screen. Rest of this can kind of stay there. We're going to be modifying that a little bit later, and we don't really need to take a look at this anymore, so I'm just going to go and hide it. We're also going to want to make some colors, as well as a useful function. So let's make some colors. We already saw how to do that, so I'm just going to make a bunch of new ones. So white, of course, is by game, make a new color, and these are RGB values, so 255, 255, 255 is white. We're going to need a black, of course. And that is 000. Maybe I'll even just copy and paste this because we're going to make use of a whole bunch of colors. As you saw, those bricks were quite the rainbow. So we need a whole bunch of colors for those. We're going to need red. Our red is going to be 255. Actually, maybe we'll make it not so saturated. 250 and 50. We need a green. I'll just paste that in, and this will be 50 red, 200 green, 200 green, and 50 blue. We of course need a blue, which is going to be very similar. 200 blue, and 50 of the other two colors. And then we're going to also want to have the in-between colors, like yellow. And that's going to be, well, yellow is between green and red. So we'll do 200 of those and then just 50 of the blue. We also want cyan. Cyan is halfway between blue and green, so we'll give it 50 red and then 200 green and 200 blue. And finally, magenta. Which is halfway between red and blue, so 200 red, 50 green, 200 blue. And we'll make one last color, a gray. And we will just put in 150 for each for our gray. Those will be the colors that I'm going to use. You're perfectly free to use different colors if you want. We're going to want to find something that will get the length of a vector for us. And unfortunately, NumPy does not have anything built in to do that. So we are going to make our own function to handle that for us. Just a quick get magnitude function here. We're going to take in a vector. And we're just going to return the length of that vector using Pythagoras. So we're going to get the x-coordinate of that vector, and we're going to square it. We're going to add to it the square of the y component, like that. And finally, we're going to take the square root by raising it to the power of 0.5. And that's it. Now that we got all that out of the way, let's start defining what our classes are going to be. So we are going to have a basic rectangle class. And what this is going to be is not actually any game element directly. Instead, those bricks that we saw as well as the paddle are both going to inherit from this rectangle class because they actually have a lot in common. They're both rectangles, they're going to be placed somewhere, and the ball is going to bounce off of them. So if we just make a rectangle class that the ball is going to be able to interact with, and we can place it and draw it really nicely, then we don't have to do a whole lot for our other, the actual brick class and the paddle class. Just the parts that are unique to those two. And so this is of course going to need to have a constructor function. And we'll just put pass there for now. We'll write that later. And it's also going to have a draw function. And we'll put a pass there because we will fill that out later as well. So all it's going to do is it's going to construct and show us how to draw the rectangle. The actual bouncing of the ball will be handled in the ball class. So let's now inherit from our rectangle class. So let's make the paddle, which will be what the player actually gets to control. And it will inherit from rectangle. So we don't have to make its draw function, but we will need to create its constructor function still. So we'll make a constructor function. that will come back to and actually fill out. And then it's going to need to have update function so that it knows how to move. And I want to do something fun with this. I want to, rather than just moving it in a linear fashion so it moves at the same speed all the time, I'm going to add a little bit of physics to this and make it so that we don't control its speed, instead we control its acceleration. And so we're going to have a little helper class here to help us do that. And we'll call it the update acceleration function. And that will be what we actually control. So this is going to be where we get the user input. And then based off of acceleration, we will then update its speed and position. So we'll do a little bit of game physics here. The other class that we're going to inherit from Rectangle is, of course, the Brick class. So it's going to inherit from Rectangle as well. And it's not going to need to have a whole lot at all. In fact, all it needs to have is its constructor function, because the Brick class doesn't really do a whole lot. It just gets hit by the ball. So we're just going to need to initialize it. Most of that initialization can be handled by actual Rectangle class. And it's not going to need to have any kind of update or anything. So that's going to be a pretty easy one to write. We're of course going to need to have a ball class. This is not going to inherit from anything, but some of the things I'm going to recommend for you to do after we're done all this to extend on this would be to make special kinds of balls, which would make this a great parent class to inherit from to do special kinds of balls. So it's going to need to have a constructor method. Just like that, which we'll come back to and write. It's also going to need to have the draw function. And it's going to need to have the update function. Remember, typically any kind of game object is going to have those three functions in it. The constructor to actually make the game object, the draw function to actually draw it on the screen, and the update function to actually update its physics and its game state stuff. We're going to want to have a couple more functions to go along with this. We're going to want to have a reset function that will allow us to reset the ball after it falls off the bottom of the screen. And we're also going to want to have a function that will handle how it bounces off of the walls. So we'll make a wall bounce function to do that. And then we'll have a function that will handle how does it bounce off of the paddle and the bricks, or just anything that is a rectangle. So we'll say it is a rect bounce function. And I'll handle how do we bounce off of different kind of rectangle objects and make sure that we're bouncing in the right direction. We're also going to have, of course, a class for making text. This we're going to come back to because we're actually going to just mostly use what we've already made for the target shooter, because we saw how to make text there. We're just going to copy and paste it over and make a couple modifications because we're doing something new in this one that gives us a little bit more power in how we place things. So, but otherwise it's going to be basically exactly the same thing that we made last time, and we're just going to copy it over. And finally, we're going to have the main class, which is going to actually take care of how everything interacts and setting up the game. So it's of course going to need to have the constructor function, it's going to need to have the update function, of course, and the draw function. So def update, draw function. And you know what, that's largely it. We will also make the event handler method that is going to allow us to handle any of those events. So basically this thing right there. So we'll say event handler, and we will actually go ahead and we're going to copy that in there right now. Let's move that entire event loop right into our event handler, and that is now basically done. So this is most of the setup that we need. We do also need to make a clock that is going to make sure that we run at a consistent frames per second. So let's make a clock. And that is going to be from Pygame time. We want to make a clock. And, well, we can actually use that clock right here. Why is my indentation a little bit off? Let's fix that. There we go. So we'll take that clock and we will make it tick at 30 frames per second. And that just prevents it from being inconsistent in how fast it's running. So sometimes if you don't have this, it can run really fast if it doesn't have a whole lot of calculations, because it's just going to go as fast as it can. Other times it will slow down a lot because it does have calculations. Doing this just makes everything run a whole lot more consistently. And then this main loop here, I suppose we can kind of finish off what code we need to do here. So we are going to need to make a main object, just like that. And that'll do all the initializing for us. And then we'll just call the methods that we need inside of this loop, remembering that this loop is going to run one frame every time it loops. So every frame, we're going to need to handle all the events. Then we're going to need to do all of our updating. And then we're going to need to draw everything. And that is our main loop. So, not going to work yet, of course. We haven't made any of our object classes. But the general structure is now there. So, let's scroll back up to the top and let's start actually filling out some of these classes so that everything works. So, let's make this rectangle class first. We only got the two functions that we need to make, the constructor and the draw function. When we're constructing it, we're going to, last time we only had one surface that we drew on. This time we're actually going to tell it what surface to draw on. So we're going to pass it what surface this rectangle should be on. We need to tell it where does it need to go. We need to say how big this rectangle is going to be. And we're also going to need to say what color we want it to be. And then all we really need to do is assign those things that we pass as parameters to class variables, and as well as make the rectangle object. So self.position is going to be position. Self.size is going to be size. Self.color is going to be the color we passed it. And self.surface is going to be what surface we want to draw it onto. Finally, let's create a rectangle for this thing. And the rectangle needs to know where to draw it and what size it should be. Here we could use self.position and self.size, but since they are the same thing, I'm just going to use the parameters that we pass to it instead. And so that's our constructor function. That's all we need to do. And then here, we just need to draw that rectangle. So we're going to use the draw method. I say draw a rectangle. We want to draw it on self.surface. We want to draw it in the color of self.color. And the rectangle that we want to draw is, of course, self.color. rect. And that's it. That is our rectangle class. And we're going to use that for both the paddle and the brick. We'll come back to the paddle. Let's just quickly do the brick since it's going to be a really short one. So we're going to want to make a couple class variables initially that they can all share. So we're going to have what colors our bricks can be. And this is going to be the order that they kind of go in. Because you notice that it kind of had that kind of a repeating rainbow effect going on. We're going to do something like that. So let's start with red. After red, we're going to have yellow. The order here is going to matter because the order that we put in here is going to be the same order that they end up showing up when we're creating them. After yellow is, of course, green. Then cyan, blue, and magenta. Those will be the 6 colors that we use in order. And then the constructor method. We, once again, need to tell it what surface we're going to draw it to, as well as the position. And this is going to be kind of not its like actual the position is going to be kind of like where it is 1, 2, or 3 in that big rectangle that we saw. So to get the color, we're going to assign a color to it. So we're going to get the colors that we made. And then we're going to do something a little bit clever here. We're going to index it by getting the X position that we want to put it in. We're going to add to it the Y position. And then we're going to use the mod method to get the remainder after we divide it by the length of how many colors we have. What this is going to do is every time one of these increases by 1, it's going to shift over 1 for the next color. So if the first color is red, its neighbor that is to the right and below it is going to be yellow. Then it's going to be green, blue, magenta, and this allows us to then cycle back. So once we get to magenta, it'll go back to red, and so on and so on. So this is going to be what actually gives us that rainbow effect, is this clever use of indexing here. The size, we're going to make this dependent on how big the surface that we passed it is going to be. So size is going to need to be an array. And we're going to make it so that we're going to get the surface. We're going to get its width. So how many pixels is it? And we're going to say that the size of these bricks is going to be 1/10 of the total width. And then we're going to do the same kind of idea. We're going to get the height of our surface. And we're going to say that its height is going to be 1/15 of the total size. And that way, when we change the size of this surface, all the bricks also get their size changed as well. So everything stays very adaptive. Now that we've done that, we can just call our parent constructor function and pass it all the information it needs in order to get it to do what it needs to do. So create a copy of the parent class, call its init function, and we need to pass it these things. We need to tell it what surface it's going to be on. We need to tell it the position it's going to be on. we need to tell it, well, the size, and then finally what color it should be. And so this constructor function is just initializing the color and the size based off of the surface and where it's going to be, and then passing all that information to the parent class so that it can take care of the rest of the details. And that is all our brick class really needs to do. So let's go back to our paddle class and maybe do that stuff now. So I'm going to say for our paddle class, all paddles are going to be white. So we're not going to do that in constructor. We're just going to say all paddles are white. And then we're going to have a couple physics variables that will help us keep things kind of responsive, not go too crazy, and make it feel right. So one of those things that we need is a drag variable. What this is going to do is that when the player is not moving the paddle and it's just drifting, this will kind of be a little bit of a friction on it to bring it to a stop, so it doesn't keep on moving at a constant speed. Then we're going to have a max speed variable, which will make sure that we don't get going too fast, and because when stuff starts moving too fast, weird things start happening. So this is going to be the max speed that we enforce and say the paddle cannot go faster than that. Now we can go into our constructor method. The only thing that we're really going to tell it is what surface it needs to get drawn on. Everything else we're going to just do directly in the constructor method. So we need to tell it how big is it going to be. This needs to once again be a vector, so turning it into an array. And I'm going to say that it's going to be 80 pixels by 10 pixels. We could also do what we did for our brick class, where we made it depend on the size of the surface itself. So that's something that you may want to do, but for now, I'm just going to say 80 by 10 is good enough. We need to get its position. What I'm going to do is we're going to start the paddle always right in the middle of the screen. So once again, we make this a vector. We're going to get the surface, get its width, and then we're going to subtract the size of our paddle and then divide that by 2, and that will be a way to make sure that it is centered in the X direction. In the Y direction, we're going to get the height of our surface. There should be an underscore right there. And then what we're going to do is we're just going to say that our paddle is always going to be 50 pixels from the bottom of that surface. Okay, so that's what that 50 represents. And this is how we can make sure that that paddle is always going to be centered. Because remember, when we're giving it position, we're always giving the position of the top left corner, not the center of the thing itself. Now that we've done that, we can actually call the parent class constructor to actually go and initialize everything else for us. So let's go ahead and do that. So call the parent constructor, and we need to pass it the surface that's going on, the position, the size, and self.color, which we defined right here to be white. But that's not all that our paddle needs. It's going to need a couple more things. It needs to have a velocity. And this is also going to be a vector. And we're going to say this thing starts at, that should be an array, not a rock. We're going to say that it starts at 0, 0, so it's not moving. And it would be a little bit useful for us to make them floating points right now. So that's why I'm going to put in the decimals there to make them float rather than ints. And we're also going to need to have its acceleration. which is also going to be a vector. And it's also not going to be moving at all, or at least not accelerating when we first construct it. So it's just going to sit there. And that's it. So the update, we are not going to be able to do quite yet, because first we're going to need to update the acceleration. And this acceleration is going to be where we actually handle the user input. I believe that last time we did just mouse inputs. So here we're going to be doing actual keyboard inputs. And I'm going to choose that we're going to control it with the left and the right arrows. You could change this to the A and D keys. That's also a standard way to do it. But for this, I'm going to show you how to do it with the left and right arrows. So, we're going to write this update acceleration function first. So we're going to need to get what keys are currently being pressed. Pygame key get what keys are being pressed. And then we're just going to go and check the left and the right arrow keys, see if they're being pressed, and set acceleration accordingly. So we're going to say if keys and give it pygame k left is the key to see if we want the left key being pressed. If it is, we're going to take our acceleration and we're going to say we are accelerating to the left. That's the negative x direction. And of course, we're not going to be moving up or down at all, so 0 for the y direction. Then we need to check if they're pushing the right key. So K right. And in that case, well, we're just going to accelerate to the right. So set our acceleration to move to the right. And otherwise, if they're not pushing either key, we then need to change our acceleration so that we apply a little bit of a drag. And that's where that drag is going to be coming in, is right here, just to slow us down a little bit. And the way that that looks like is we take our acceleration, and our acceleration is going to be the negative of our velocity times that drag. So drag is basically about 5%. We're going to accelerate at 5% of our velocity in the opposite direction that we're moving. So this is going to slow us down. And that's it. That updates all of our acceleration depending on what kind of inputs we're getting from the keyboard. Now we're ready to go and do our update function. So, first thing we need to update is we need to update our acceleration. So, self.update our acceleration. Done. Now we can update our velocity. So self.velocity, we're going to add whatever our acceleration is. After we've done that, we now need to enforce our maximum velocity because it's possible now we're going faster than we should be going. So let's enforce our maximum velocity. So we're going to check if we're going faster than we should be by using that get magnitude function that we wrote. And we're going to get the magnitude of our velocity and just see, hey, are we going faster than our max speed? If we are, then we need to set our velocity to have a magnitude of our max speed. And the way that we can do this is we can take our velocity, we're going to multiply it by our max speed and divide it by our magnitude of our velocity. So this step, the dividing, is going to set our speed, not our velocity, but our speed to 1, and then when we multiply it by self.max speed, that will set our speed to the maximum speed. So that's how this is working. First, set our speed to 1, and then set it to the max speed. And that enforces our maximum speed, so we're not going too fast. Now, we need to update our position. So it's always update acceleration first, then update your velocity, then update your position whenever you're doing any kind of physics stuff. So self-dot position is going to be just add our velocity to it. And now we need to check to see if we hit any of the walls. And if we do, we need to bounce off of them. So let's check if we hit a wall. So if self-dot position, the x coordinate is less than 0, meaning that we hit the left side, or the x coordinate is greater than the surface width. So get that width again. And we need to subtract its own length. The reason why is because, once again, that position is representing the top left corner. So we need to check when the top right corner, or just the right side, hits, and so that's why we need to have this part. So if we hit either wall, then we need to check which wall that we bounced off of, and set our position so that we don't clip through it. So if self-dot position x is less than 0, then let's just set our position to 0 so we don't clip through that wall. And if it's not the left wall that we went through, then it must be the right wall that we went through. In which case, we'll take our position and we'll just set it to, well, this thing, which is as far right as we're allowed to go. And so that handles making sure that we don't go through the wall. And finally, we also are going to make it so that we bounce off that wall. So after we fix our position, let's take our velocity and we'll just multiply it by -1. So now we're going to move in the opposite direction, and that will have a nice little bounce effect whenever we run into the walls. Last thing we need to do, though, we're almost done, is we need to update our rectangle so that we're going to be able to draw it in the right spot. So self.rect, we need to update it by creating a new rectangle, giving it our position and our size, just like that. So now everything's updated and we're ready to go. So that is the paddle all done. The ball, I suppose, naturally should come next. This is also going to have a couple parameters that we need to define before we get to the constructor method. One is we need to get its speed. We're going to want our ball to move at a constant speed, so I'm going to just say it's going to move at a speed of 5. You could randomize this, but I find that the game plays better if you have a constant speed for your ball. And then we're going to actually make use of some of those matrices that we imported in order to help us with bouncing off of the corners of the rectangles. So we're going to have one that's going to help us reflect off of the 45-degree angle. And for that, we're going to make a matrix. And the matrix looks something like this. Essentially what it is doing is when we multiply a vector by this matrix, what it's going to do is it's going to reverse the X and the Y coordinates. And that's how you reflect at a 45-degree angle. We're also going to need to reflect over the 135-degree angle, which is going the other direction. So 135, matrix also, and it is quite similar, but it also inverts both the X and the Y coordinates when you multiply it by this. So, never seen matrices before, but when you go into university, first year university, you will learn about matrices, and they can be really useful for doing transformations. In fact, there are matrices that allow you to reflect over any kind of angle, or doing any kind of different transformation that might be useful. But we're going to just stick with these two to help simplify our lives with this. Now that those are made, we can go into our constructor method. Just like the paddle, the only thing that the ball needs is to know what surface is it getting drawn to. And then we're going to say, well, self.surface is surface. We don't have a parent class that we can send all this to, so we're going to have to kind of just do it ourselves. And you may need to generalize this for yourself later if you want to use this as a base class and have other special kind of balls that do different things. And you do it basically the same way that we did with the rectangle, where all of the generic stuff would happen here, and then the specific stuff would happen in the children classes, like the brick and the paddle did. So we're going to need to have a color, of course. I'm going to use gray for this, just to make it a little bit different from all the other ones. We need to have a size, and I'm going to say it just has a fixed size of 10 pixels. And at this point, we're going to actually make use of a couple of the things that we already are going to be making. So I am going to just call the reset function here that we haven't made yet. But the idea is that the reset function is going to position the ball back at a center location, and then kind of randomize what direction it's going to go. So rather than doing all that here, we may as well just let the reset function take care of that for us so that we don't have duplicate code. We're also going to draw it right away because we're going to put in a little bit of a timer on it so that as soon as we construct it, we can see it, make things a little bit useful for us. Actually, I don't even remember if this is necessary. Maybe we'll take it out and we'll come back if it's something we really need. And then there's one other thing we're going to have, and that is something I'm going to call last bounce. And this is going to start off as none. What this last bounce is going to do is it's going to store what was the last thing we bounced off of. Specifically paddle, bricks, that kind of thing. The reason why we're going to do that is because sometimes you can encounter an issue where an object will bounce, or the ball will bounce off of the object multiple times and sometimes get stuck inside of it. So if we keep track of what was the last thing that we bounced off of, we're going to make it so that it can't bounce off of that again. And that way we don't have to worry about it getting stuck inside of something. It'll just bounce off of it once, then it'll hit a wall or something and bounce off of something else before it's allowed to actually bounce off that same object again. The draw is going to be really simple. We've already seen how to draw in our target shooter. The draw function also does actually return a rectangle. Oh, right. So this is why we are going to call the draw in order to set the rectangle. So why don't we just do that right away. So we'll put the draw back because it's going to also update our rectangle for us. And then we will just draw it how we normally draw circles. So we need to tell it what surface it's going to draw on. We need to tell it the color. So self.color. We need to tell it the position to draw at, as well as how big of a circle should it make. So this is going to draw it, but also at the same time update our rectangle that we're going to use in order to check for collisions. Update. We're not going to do the update yet. Let's do the reset and then these two bounce functions, because they're all going to be used in our update method here. So reset is just going to set the ball back to the center and then randomize its direction. So we need to set its position. It's going to be a vector. And we're going to do it same way that we did it with the paddle. So we're going to get the surface, get its width, and then we're just going to say its x position is going to be half of the width. And then we're going to get the surface again, get its height, and we're going to say that the ball is going to start 150 pixels from the bottom. So that's going to put it 100 pixels above the paddle. After that, we're going to then generate a random angle that is going to start going in, and we want this to always go upwards. So the way that we're going to do that is we need it to be negative in order to make it actually go up. Otherwise, it's going to start going down. And we need it to be in radians, because all of our trig functions only work with radians. And then we're going to use the random uniform method rather than randint. This is going to get us a floating point instead, rather than an integer. And we're going to say we want to get a random angle between 10 and 170 degrees. So this is going to make sure that we are always going to have the ball initially going up, but it can go in a wide angle somehow going up. We could have an issue if it went totally horizontal, then we wouldn't be able to play it at all. So this also helps ensure that it's always going to be playable. Now that we got that angle, we can use it to set our initial velocity. Our velocity is going to be our speed times a vector made from that angle and some trig functions. So to get the x coordinate, that's going to be the cosine of our angle, just like how we do it in physics class. And of course the y coordinate is going to be the sine of that angle. So that sets the direction. Multiplying by the speed then stretches it out so that it is going as fast as we want it to be. And that is what our reset is going to do. And that's why we call it in the constructor, in order to initialize both the position and the velocity. Wall bounce is going to also be pretty much the same thing that we saw in the target shooter. So we're just going to check to see if we are well, in the Y position, we can only really bounce off of the top wall. So we'll check if we are going too high. So we will get its Y coordinate and check if it is less than our size. That will check to see if we hit the top wall. We don't care about hitting the bottom wall because remember it can drop off. That's perfectly fine. And if it is, we're going to take our y velocity or y component of our velocity and multiply it by -1, so we now go downwards. And we're also going to set that the last thing that we bounce off of, well, we don't really have a wall object, so we're just going to say none, and so it's allowed to bounce off of other stuff again. Same idea in the x direction, just a little bit of a larger condition here. So we need to first check if we bounced off of the left wall. So self.size. That's going to check if we bounce off of the left wall. And then same thing over here. Get the x coordinate and check if it is bigger than, well, the surface width minus the size. Self.surface get width and subtract our size. And if either of those things are true, then we are going to multiply our x coordinate by -1 and also set that the last thing we bounced off of is nothing. There we go. Our wall bounce is all done. Rectangle bounce is going to be a little bit more work, but we may as well take care of it now. So first thing we need to do is we need to know what rectangle are we bouncing off of. Remember, this rectangle can be the paddle or any of the bricks. And so, first thing we're going to do is we're going to check is that rectangle the same thing as the last thing that we bounced off of. And that should be a double equal. There we go. If it is, we're not going to do a thing. We're just going to exit the function right away. And that's going to prevent any kind of bugs of having the ball bouncing around inside of our rectangles. After that, so it's not the same thing we bounced off last time, so we are going to bounce off of it. And so we're going to say the last thing we bounced off of is this rectangle that we passed it. And now we need to go and check to see, first of all, what side that we bounced off of. Did we bounce off of one of the left or right sides? Did we bounce off the top or the bottom? Or did we hit one of the corners? And if we did, what corner? So, we are going to make a boolean to tell us, first of all, if we bounce off a corner, what corner it is. So I'm going to call this the 45-degree reference, or ref 45. And to do that, we're going to get that rectangle, access its rectangle, because remember this is like a paddle or something. It has a rectangle object associated with it. We're going to get its center of its x, and we're going to subtract the x position of our ball. And then we're going to do the same thing in the y direction. And this is just going to tell me kind of, is it to the left or the right, and is it to the top or the bottom of the ball that we bounced off of, or rectangle that we bounced off of. Center y minus self dot position 1, and we're going to ask, is this thing negative? So think of it like this: if we are on a 45-degree angle, that means that just think about like the rectangle being in place, and it's 0, 0, and the ball is going to be in one of our coordinates. If it is in the first quadrant, it's going to be the top right of it, which means that both of these are going to be positive, and so this is not going to be true. Also, if it is in the third quadrant, then both of these are going to be negative, and so this is also not going to be true. And the way that we bounce off of something in the fourth quadrant or the third quadrant and the first quadrant is going to be the same. But if the ball is in the second or fourth quadrant relative to the center of our rectangle, then one of these is going to be positive and the other one is going to be negative. And so that is going to tell us that we need to bounce off of those in a different way. And that's just going to help us identify which of those matrices that we made earlier on we should use for the bounce. So, and it may be a little bit, oh, I don't need that. So that is just telling us basically what quadrant are we in. If this is true, the ball is in the second or fourth quadrant. If this is false, then it's in the first or the third quadrant. So we're not going to use that right away. But we're going to instead check to see if we bounced off of the sides. And so the way that we do that is we're going to check to see if we bounced off of either the left or the right side by checking to see is the center of the ball in between the top and the bottom sides of the rectangle. So get its X position, check if the ball's X position is between it and X position plus its size. So, is the ball between the top and the bottom of the rectangle? If it is, then it must have bounced off of the side, and so we are just going to take our y coordinate, or sorry, this is in the x coordinate, so this is actually checking to see if we bounce off of it's the ball between the left and the right side, sorry, not the top and the bottom. So this is the left side, this is the right side. Is the ball somewhere between the two? If it is, so we're bouncing off the top or the bottom of this rectangle. We're going to get our velocity, our y velocity, and multiply by -1. And that will bounce off of how we bounce if we hit the top or the bottom. Then we'll do the same kind of idea. In fact, I'm going to copy and paste all this. And then change it to an elif, because we want to chain it all together. And then switch all of these to check for the y coordinates. And this will check if we're between the top and the bottom of the rectangle. And if it is, we hit either the left or the right side, and so we should reflect our x velocity. So, quite similar to the way that we did the balls, just checking to see what side that we bounce off of is a little bit more complicated. Next, we're going to now use that Ref45 method. Say, okay, should we be reflecting this vector over the 45-degree line? If it is, we're going to use our 45-degree reflection matrix. Otherwise, we're going to use the other reflection matrix. And the way this works is we get our velocity. It's going to set it equal to, and use that matrix multiply method that we imported. We're going to give it the reflect 45-degree matrix and tell it to reflect our velocity over it. But this does not actually give us the array that we want. In order to get a vector back that we can use as a velocity, we actually need to turn this into an array and then access the first thing in that array. So fortunately, it doesn't do it in a nice way. This is kind of the way that we can get around that so that we do actually get the vector back that we want. Else, exactly the same thing, but so I'm just going to copy and paste it, but we're going to use the other reflection matrix that we made. There we go. And yeah, that is everything. So this is reflecting off of either the top or the bottom. This is reflecting from one of the sides. This is going to reflect off of the top left or the bottom right corner. And this is going to reflect off of the bottom left or the top right corner. And there we go. So now we can go back and we just got this update function that we need to make. And then our ball is all done. So we will first see if we need to bounce off of a wall. So call our wall bounce function that handle that. Then we will update our position with our velocity. And then we're going to check to see if our ball fell off the bottom of the screen, which means that they lost the ball, and we should reset it back to where it initially was. So let's check to see if it went too far down. If our Y position is greater than the height of the entire thing, which means it's gone off the bottom. Then let's just call our reset function. And it'll reset the ball and start all over again. So, nice and simple. That should be all the main things that we need. So we could probably go down and start our main class, where that's going to actually put it all together and handle the different interactions. So we're not going to handle the text yet. We're going to add that later. Because what we're going to do is have the main game window be broken up into two parts. One where the game part is happening, and then we're going to have a banner up top where we're going to put some text. And what that allows us to do is kind of deal with each one of them independently, and rather than having to offset everything so that they fit nicely, we can just treat them as two kind of different frames. We place the frames separately, but everything that's in that frame will deal with the top left corner of the frame rather than top left corner of the window itself. So, we're going to need to make the game surface. So self.game surface, we're going to make a new surface. So game, make a surface. This just needs to know how big it's going to be. So, what we're going to do is kind of like the size. It's going to go across the whole width. So, window width is going to be how wide it is. But, we don't want it to take up the whole height. We do want to give it some space up at the top. So, we're going to say its height is actually going to be the window height times 4/5. And so it's going to take up 4/5 of the total height, but take up the entire width. Then we need to give it a position. So the game surface position is going to be x coordinate is going to be 0. It's going to be all the way to the left. But we want to leave the top fifth of the window for our little banner header. So we're going to set its Y position to be the window height times, or maybe we'll do times 1/5 just so it's consistent. Technically, I don't need to put the 1 in there, but we say, okay, it's going to be 1/5 of the way down. Now that we made the game surface, we can make the stuff that's going to be on the game surface. So let's make a paddle. Self-top paddle, we're going to make a new paddle, and it's going to be on the game surface. We're going to make the ball. And that's also going to be on the game surface. And then we're going to need to make the bricks. The bricks we're going to store in a list. So I'm just going to make an empty list for it right now. And then we'll make a for loop that will then put it all onto the screen for us. So we're going to say for column and range 10. So we're going to have 10 columns, and then we're going to have 8 rows. So 4 row and range 10. 8 rows, sorry. Because I found that worked pretty well. And yeah. Now we're just going to get our bricks. Why it's down there? Should be over here. There we go. And we're going to add bricks to it. So column and row is going to represent what position do we want these things to show up at. So we're going to create a new brick. It's going to be on the game surface. And it's going to be in position row, column. Just like that. Guess we'll do the draw. That'll be really easy. All we really need to do is go through all of our different game objects and draw them. So let's get the ball, call its draw function. Let's get the paddle, call its draw function. I suppose we do want to give it the background first. Always need to draw the background first. So get the game surface and let's fill it as black. The black background. Then draw the ball and the paddle over top of it. And then we need to go through all of our bricks and draw them as well. So for brick in self.bricks, we'll take our brick and call it draw function. And that should be pretty much it. We do now need to actually take our surface and draw it on the main game window. So we did call it, I'm going to call this, yeah, display surface is fine. So we're going to take display surface. We need to blit, which is a kind of draw. Basically paste this game surface onto the main display surface. And we're going to say get our game surface, and we're going to want to draw that on at the game surface position. And that's going to be how we actually take the surface that we made and get it to show up on the main game. Update. We still need to write that one, so let's do that now. What we're going to need to do is update, of course, the ball and the paddle, but we're also going to need to check to see if the ball has collided with anything. Because you notice we haven't actually used this rectangle bounce function yet. So we need to go and check to see whether or not they've ran into anything. And if they did, then we need to call that function that's going to handle bouncing off of the object. So we are going to first check to see if we ran into any of the bricks. And Pygame has a useful method to allow us to do that, where we can just get the index of what we may have ran into. So we're going to say self.ball, get its rectangle, and we're going to say check if you collided with any of these things. And then we're going to use a list comprehension here to make it a little bit easier. So we're going to say check if it collided with the rectangle of X for every, actually maybe let's call it brick just to make it a little bit clearer what this is. So check if you ran into the bricks rectangle for every brick in self.bricks. Just like that. And what this is going to do is the collide list is just checking to see do any of these rectangles overlap. And this is just going to be the list of all the rectangles for every brick that is still in play. Then we're going to need to say, okay, if index is not equal to -1, and remember, when we were doing the different algorithms, especially the searching algorithm, -1 indicated that it did not find it. Same thing here. So if index is -1, it means it did not find the ball ran into anything. So if it's not -1, it ran into something, and index is the index of the brick in our list that it ran into. And so what we need to do is then bounce off of that brick. So get our ball. We're going to bounce off of a rectangle. And what rectangle are we going to bounce off of? Well, the one at the index that we found. And after it bounced off of it, since the bricks only need to get hit once, we are just going to remove that brick from our list of bricks, just like that. And the brick will disappear. We're not going to draw it anymore, it's just gone. So that handles bouncing off the bricks. We also need to check to see if it collided with our paddle. So let's check for that next. And once again, Pygame has a useful tool that will allow us just to see if it collided with another rectangle. So we're going to get that ball. We're going to get its rectangle. And we're going to say, did you collide with another rectangle? And what rectangle do we want to check if you collided with? Well, the paddle rectangle. So, did the ball and the paddle collide? Did the rectangles overlap at all? If it is, then once again, we're going to call the rectangle bounce function. And we're going to give it the paddle. And that's what you bounced off of. Now that all the bouncing off of different objects is handled, we can now just do the rest of the updating. So self.paddle needs to update, and self.ball needs to update. There we go. So, I believe if we run this now, we should actually have a functioning game. So fingers crossed. I'm going to bring all this back. And let's see if I made any mistakes writing all of this code. Oh, I did something wrong in the paddle class. 939. Let's see. This is the paddle class, right? Yep. And 939 cannot interpret 350 as a data type. Oh. See. Why might it be doing that? Surface, get width, size 0, take the entire thing, divide by 2. Oh. Did I not close this properly? I don't think I closed this properly. Yeah, I'm missing some brackets. It's actually evaluating the entire thing. That looks like it might work a little bit better. Because we always need to make a tuple first, and I was not doing that here. Alright, let's see if we got any more bugs. Oh. And then down here, I said key, not keys. Okay. Fix that. Try again. Did you guys catch those errors before I did? Or are we fixing them all together? Alright. Why is it not wanting to play? Might need to refresh everything. So let's just refresh everything. See if that fixes that. Oh, there we go. Do have some stuff happening. And okay, that's moving. Alright, we ran into a problem in the paddle update. Right there. And update, line 61, right here. Why does it not like that? This is for the paddle. And also we had a problem with the bricks not being positioned quite right. I think I know what I did with that one too, but that'll be an easy fix. Argument must be rect style argument. That should be what it is. Or I think position or size got messed up somehow. Oh. Oh, we set position to be a number here. We need to set it to be the X position. And let's actually go and fix those bricks as well. Yeah. Down here, where is it? The ball, bricks. Position, we actually need to multiply by size here, because position is actually just like 1, 2, 3, 4, whatever. and that's just kind of representing what row and column it's going to be. If we multiply by size though, that's going to shift them over by whatever size they need, and that should fix that issue. Oh, it's our runtime. A little bit long. Hey, yeah, that's starting to look pretty good. Okay, bouncing around. Bricks are going away. Yeah. Bouncing nicely. Look at all that. And notice, oh, I think we might need to make our brick count a little bit larger. Oh, I think I got our row and columns backwards. I wanted to go 8 across and, or 10 across and 8 down. It's going 8 across and 10 down. So let's go and fix that right now. Let's just go and change this to column first and then row, because column represents the X position and the row represents the Y position. So those were just backwards. That should fix that issue. You're going to run for us. There we go. Looking pretty good. Everything's bouncing really nice. Bounce off the walls, all good. And our drag is working. Yeah. So it looks like we got a working game here. Just had a couple things that we had to fix. Now let's go and see the power of having multiple surfaces so that we can deal with them independently by putting a banner up at the top with the title of the game. And then we'll be all done. So we'll stop this and let's go down to our text objects that we haven't done anything with. And what I'm going to do is I'm going to actually just copy and paste the text object that we made last time, because there's no reason to rewrite it if we've already got it made. Just like that. So this should look familiar. If it doesn't, go and take a look at your target shooter, and it should look exactly like this, because we can use this to make any kind of text that we want, but we just need to modify it because we're not going to go just right on the display surface. Instead, we're going to tell it what surface that we want to put it on. So we need to make a couple modifications to it, and we're going to do those modifications right now by saying what surface we want to pass it to. Text, all this stuff still stays the same. Remember, we gave it a default size of 30 pixels and a default color of black. This is the text of what we want it to actually say, as well as where. And then we're going to have a self.surface once again. It's going to be the surface that we pass to it. Like that. And then rather than using display surface down here, we're going to do self.surface. And that should be the only changes that we need to make. Now it's going to use a custom surface that we pass to it rather than going directly on the main display surface. And so now let's go down to our main object here. We're going to then make a new surface that's going to be the top banner. And we're going to put some text there, position it in the center real nice, and we will be all done. So we'll make a new surface. It's going to be the text surface. Pygame. Surface. Should be capitalized, just like how we made the one right below. And this is going to be window width, long, and window height, but only 1/5 of it tall, just like that. And it's going to also have a position, text surface, position, and it's going to go right in the top corner. There we go. Now we need to put some text on that surface. So the title is going to be our text. We're going to make some new text for it. It's going to go on the text surface. It's going to say Breakout, because that's the name of the game. And then we want to give it a position, and we want it to position it so that it is right in the center. And the way that we can do that is we get the text surface rectangle, or get rectangle, and then pass it the center. Just want to quickly verify that there's nothing else that we need to do for the position, because I think that we had it so that it's centered here as well. No, we have it, the position going to the top left. Let's have it so that when we pass a position, that's actually going to be the center of our text. So we'll change that as well. And down here, okay, title's already made. Looking pretty good. I think that's all we need to do in our constructor method. And it's never going to get updated. So then we just need to go and do the drawing. So we can go and do that right now. We're just going to, well, we need to fill in the background. Text surface. We need to fill it. This time I'm going to fill it white. And then we're going to take the title and we're going to draw it onto that surface. And then we need to then draw our display surface on, or our text surface onto our display surface. So display surface, we're going to blit our text surface in the text surface position. And there we go. That should now give us a banner right at the top. So run it one more time. I think that we might also want to give it a size. I think that I made it quite small, the text itself. So we may need to go back and fix that. Okay, about to run. Let's see. Yeah. Here we didn't give it a size, so it's going to use the default size, which was 30 pixels. We wanted to make it quite a bit bigger, so we're going to go 100 pixels. And now we're getting an error. Oh, no. Yeah, you can see it's actually super, super small. But we do have the white background, so that surface is in fact working, and it did in fact center it really nicely. Don't know why it's that small. I'm not expecting it to be quite that small. But let's try again. Now that we put in the size to be 100. And hopefully, that's the last thing we need to do. There we go. Perfect. So here's our text showing up nice and big. Game is still working fine. Oh, that's kind of a weird bounce. But there we go. So now we got a functioning version of Breakout, the classic Atari game. So what you're going to do now is, of course, comment on all of this because I did not actually add any comments to the code. So you'll need to go back and do that. And then you'll need to add additional features to this in order to get a higher grade than developing. So, as I kind of hinted at, you might want to make multiple types of balls that do different things. Um, you may also want to add multiple types of paddles. And what you would do is then use the paddle class and the ball class that we had, maybe modify them slightly and turn them into a parent class that you can then inherit and use that for something more custom made. So you can make custom made balls, etc. Once again, this doesn't have any kind of score. It doesn't end at any point. When all these are gone, it'll just keep on going. So you probably want to add some sort of end game feature. Maybe have some customization. So buttons that they can choose, like what level they want to go at, etc. So just some ideas of what you want to do. Even the bricks themselves, maybe you want to put in some special bricks that have special things happen when you break them, or bricks that take more than one hit, reinforced bricks. And all that is certainly possible with what we've done because we've done it in a very general way that allows us to use inheritance to then build off the top of these generic versions of the ball, the paddle, and the bricks. So I will leave it there. And check out the assignment outline for some more ideas of what additional features you may want to add. Alright, have a good one, and I will see you later.